All right, let's get started with this problem. Day 4, giant squid. You are already almost 1.5 kilometers, almost a mile, below the surface of the ocean, already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Maybe it wants to play bingo? Not sure if I get that reference. I'm going to click on this link real quickly. It's telling me what bingo is. It actually wants to play bingo. It's not a joke or anything like that. Bingo is played on a set of boards, each consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers win in any row or column of a board are marked, if all numbers in any row or any column of a board are marked, that board wins. Diagonals don't count. The submarine has a bingo subsystem to help passengers, currently you and the giant squid, pass the time. It automatically generates a random order in which to draw numbers in a random set of boards. Your puzzle input. For example, all right, there's some examples here. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. Okay. I think we kind of understand the rules of bingo. So at some point, a board wins. The third board wins in the example. It has at least one complete row or column of marked numbers. In this case, the entire top row is marked blah, blah, blah. The score of the winning board can now be calculated. Start by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won. 24 to get the final score, 188 times 24. To guarantee victory against the giant squid, figure out which board will win first. What will your final score be if you choose that board? Okay, so really quickly to review the way that we calculate the final number, we essentially run a bingo simulation. And then once we've determined that one of the boards has won, the first one that wins, we take a look at that board. We grab all of the numbers that weren't called for that board, and we add them up, and then we multiply that by the number that was just called, so the number that the winning number. So essentially what we need to do is keep track of the state of all of the boards, be able to run a verification on each board to determine whether or not it has won, and then just do some simple math over it. So that's not too bad. Okie doke. This one's interesting because there's probably lots and lots of different ways to model the boards and remember which values have been already called. Now, if I remember correctly, each board has, I think in bingo you can only have one, like each value on a board has to be unique. So that is actually an interesting thing to think about. Let me take a look at what the input looks like. Okay, got it. So the input, actually for this particular problem, parsing the input might be one of the challenges that we'll have to deal with, right? Because for most days of Advent of code, each line of input is consistent, but in this case, like we've got all kinds of variety. Like essentially multiple lines form a single unit of data, and then like this first line is just something totally different. So we'll actually have to have like essentially like a stateful parser that we'll need to figure stuff out here, which is not a big deal. Okie doke. Let's go ahead and make our project directory from our template. O4 part 1 or O4A. Now that we've got that going, we're going to just make sure that the manifest file has the right name. Let's go ahead and just like see if it'll run. It does. Usually what needs to happen when I create a new directory like this is I need to reload Visual Studio Code just to get language services working correctly. And let's see if I hover here. Yes, language services are now working, which is great. All right, so the first order of business is to just figure out how to parse our input. So let's grab the input really quick. I'm gonna just copy it and then paste it into our input file. So the first line is a bunch of comma-separated numbers, which is basically the numbers that are being called. And then we go ahead and we parse out each board. Okay. So let's actually just go ahead and like split our input into lines. It's probably an easier thing to work with. And maybe actually, like, can I collect these into a vector? That might be a little bit easier. Okay, great. So now we've got lines in a vector, and now we can kind of work on them a little bit more effectively. Does this have a delete or remove index? I'm not really concerned about performance here. The reason why I like to remove is that way I can kind of remove the first line, which is a little bit inconvenient to work with. I think Rust might also have a split at that'll let us do this. Yeah, let's go ahead and do that. Split at 1. And I think this returns a tuple of vectors. Is that correct? Yeah. Got to keep input in scope. If it goes out of scope, we lose our references to strings. I just got a DM from a friend who may want to join us on the stream. So I'm going to try to figure out how to get a conversation with him going, maybe through Discord. So I'm going to go ahead and pause the stream real quick, and hopefully we'll be back in about 5 minutes or so. And hopefully have somebody that's joining me. And hello, can you hear me?
I can still hear you.
Okay.
Ooh, I see more noise this time.
Yes. So I think we are now in business. Sorry, that was exceptionally complicated.
No, it's fascinating. I learned some stuff about audio engineering today.
Okay. So let me just double check and make sure that the stream is working on Twitch. People may show up today, people may not. Let's just pretend that they're not. And we'll just do a problem together. How's that sound?
Sounds delightful.
Okay. Have you done Evan of Code before? Oh, yeah, you did.
I haven't.
Yeah, that's
Yeah,
right.
I used to do it a bunch. I was pretty competitive until kids appeared.
Oh, okay. Nice. So did you ever leaderboard in the top 100?
I did, yeah. The two feathers in my cap are 1 year I was in the top 100 globally. And on one of those problems, the person right below me in the timing was Peter Norvig.
I love it. That's incredible. Peter Norvig last year, I think or the year before, he kind of had this like blog where he was kind of trying to blog everyone, and then like he got to one where he just complained about it, which was funny. I thought it was really amusing. But so let me go ahead and I guess we can just pretend like I'm going to restart the stream. I just started when you messaged me, but I'm glad you did. I'm glad you reached out. This is going to be really fun. This year's theme is that you're in a submarine, I guess. So I guess it's in line with like a Beatles theme in pop culture right now. So I'll go ahead and read this out loud just so you've got the context. We're not deep enough into the competition where there's anything that relies on like past knowledge or anything like that. Every problem so far has been just totally original. Anyways, today's problem is called Giant Squid. This is technically yesterday's problem, but whatever. We can't all do it.
We can get Bruce Schneider in here this time with the squid.
Yeah. You're already almost at 1.5 kilometers. Okay, so the idea here is that we're actually just doing a bingo game, right? And what we do with bingo is we're essentially given an input that describes on the first line the sequence of numbers that are called out in bingo. And then in subsequent lines, it's basically just like the layout of a board. Or actually multiple boards. So we just imagine that there's like multiple players, each one of them with their own board. And what we're supposed to do is sort of parse this file, create some modeling of these boards, and then run a bingo simulation where we call out the numbers in sequence. And the real challenge of this is just figure out which board wins first. A win is if you have called out all 5 numbers in a row or all 5 numbers in a column. They're not doing diagonals.
Oh, good.
Yeah. I'm guessing part 2, they're going to start doing wildcards or something like that. That's probably the curveball that they're going to throw our way. I don't really know. But part 1, we just have to figure out the winning board. And the way that we figure out the winning board is that we essentially take all of the values on that board that haven't been called yet, and then add them up and multiply it by the number that was just called. It's kind of this like extremely obtuse way of like essentially encoding which board is the winner, right? I guess that prevents us from brute forcing it.
Yeah, for sure.
So this actually happens to be one of those problems that has an annoying parse step. Right, it takes a little while to parse because it's like usually it's like line by line, like each line has a consistent structure. But in this case, we might have to have like a little bit of state or knowledge of how things go. Compounding the complexity for me this time is that I'm trying to do this in Rust, which I've done the last 3 or 4 years in Advent of Code, and what happens is that like that's the only time I ever use Rust, and so I forget everything about the language. So you're gonna have to bear with me here as I try to recall how this works in the first place.
Well, if it makes you feel better, I know literally nothing about Rust other than people like it and it sounds cool. So you're gonna look like a genius.
So I don't know how much you've heard about Rust, but the famous thing about Rust is the borrow checker. The idea behind it is that you can only have one mutable reference to a variable at a time. And the goal of that is to make sure that you don't try to modify the same variable concurrently, right?
Yeah, that's an interesting locking mechanism.
Exactly. Only it basically handles that statically. But what that means is you have to be extremely intentional about like how you use your variables. And it can be very, very annoying. And you also end up like passing references to stack allocated variables around a lot just without you even realizing it, right? Like you just completely take it for granted in every other language. But it matters when you're taking references to things because essentially they want to make sure that you don't do the thing in C where you pass a pointer to a stack allocated variable and then that stack frame goes away, and that maybe that pointer is still floating around out there, right? Yeah.
So you can only pass those references down. Does it check on that, or is it okay with you passing them up as long as you're extremely careful?
It will complain. It won't let it. The program will fail to compile because it does lifetime analysis of stack allocated variables and the references thereof. So basically, there's a lot of energy spent in like making sure things that are like carefully allocated to the heap if they have to be on the heap rather than the stack, and then also just making sure you're not like trying to do use after free or that kind of thing, you know. And it gets really tricky because modeling a lot of advent of code problems involves nested data structures in particular, right? Like I want to have yesterday nights I had like a vector of vectors, right? But then I wanted to create copies of those vectors of vectors. And I actually had to laboriously go in and like explicitly say, I want to deep copy these vectors of vectors. Because otherwise, like I would be like referencing data twice because I was making shallow copies as opposed to deep copy. You know, there's all these kinds of things that I wouldn't have had to worry about if I was just writing this in like JavaScript or whatever. But whatever, that's part of the fun. It's like trying to like add these like constraints, I think.
Yeah, finding like elegant solutions to those annoying bits. I've always I haven't yet, but I'm meaning to do advent of code in a super functional language. Maybe not as far as Haskell,
like
but
Clojure or something like that.
Yeah. See how that goes.
Yeah, I mean, you could do it in like OCaml or something like that. And in fact, if you write Rust in a functional way, a lot of like the borrow checker and lifetime checker problems go away. Because you're essentially like passing everything into functions, and when those functions return, you're passing the result back. And you never have like pointers just living in other places, generally speaking. All right, so it'll be enough of a challenge for me to just remember all of like my string manipulation primitives to do the parsing here, but I'll kind of walk you through what I've got so far. So I have my kind of Rust program here, and the way that I'm running this is actually, let's get a println in there, just so we can see that I'm doing things correctly. So basically I have kind of this like make file that has a lot of like makefile magic in here. It took me an embarrassingly long time to set this up because makefiles are kind of user hostile. But the idea is I have a bunch of directories in my advent of code directory, one for every problem to solve. So I'm not like sticking part 1 and part 2 into the same project file. I just essentially create a new directory for each individual discrete problem to answer. And I'll just copy like part 1 into the part 2 folder, right, when I get there. And I just need to type make into the name of the directory. And what that will do is it will just compile that directory's project. And if there's a file called input, and in this case, we do have a file called input, the make file, like if there's a file called input, then it'll basically pipe that input into the resulting compiled executable. Otherwise, it'll just run the executable. And the reason why we don't always have an input file is that I think some days the input's just like one line. Or it's just like a single number. And in those days, I don't bother like parsing input. I just like stick it into the file itself.
Yeah, for sure.
Okay. So what I've got so far is just like a really bare bones things. Like I have this function that basically exists in most projects, most days projects, which is it just reads the input from standard in, right? Because I'm piping in. And I think you can already see the complexity of Rust in here, where I actually have to lock standard in order to read from it. Because Rust assumes that you're probably writing systems programming, you're probably doing multi-thread or async programming. And in that case, you just want to make sure that you're not modifying the same thing across different threads. And because standard in is like a stream, when you read from it, it's technically mutating it, right? Because you're like modifying a stream pointer or something. Yeah. Cool. And then I am basically, it's, you're reading into a string and you're passing it in this sort of like a mutable reference. So you think about this as like a pointer to memory that is actually writable. Everything in Rust is default const unless you tell it that it's mutable. Right. That's actually kind of a nice thing. I think probably most
up on line 5 where you have like a vec of ampersand string. Does that mean a vec of immutable references, or just reference it doesn't care and you pick it at write time?
It is an immutable reference. Yeah. This is a immutable reference to strings, and then strings are slices of characters. I think they're UTF-8 characters. Yeah. Now that is actually, you'll notice that we have this funky notation, ampersand string, and then we also have this notation, which is like capital S string. And capital S string is the heap allocated equivalent of ampersand string. With ampersand string, it doesn't know whether the actual buffer of characters is allocated on the stack or the heap. That's not what this particular like notation cares about. With string, you have explicitly moved the buffer onto the heap, and therefore it's actually easier to kind of like pass this string object around to different functions without having to worry about it getting deallocated if a stack frame goes out of scope.
For sure.
Now, the exact subtleties of sort of like working through those, I've kind of like maybe deliberately chosen not to not to kind of like learn super clearly, and it's kind of bit me in the ass repeatedly. But like I basically like the way that I think most people deal with the borrow checker and the lifetime checkers is just kind of like bash it over the head with a hammer until stuff works. So you end up doing like I'm just gonna like clone this data inefficiently until like the borrow checker says, okay, I'm satisfied that you've made a copy of this thing and it doesn't care anymore.
Sure.
Yeah. I've got a comment in chat from Arisa Snowbell who has sent us a link called Cargo AOC, which is a tool for managing advent of code using Cargo, and Cargo is essentially the npm of Rust. You can see in my project files I've got cargo.toml, cargo.lock. Technically, you don't have to use Cargo. Like you can just run the Rust compiler over a Rust file and just run. It's a little bit overkill in this case, but frequently I'll need like one or two packages. I'm trying to do this in a way that doesn't involve any kind of dependency usage, but I'll give you an example. Like regular expressions are not in the Rust standard library, and
really?
Yeah, it's kind of surprising. I think it's in the nursery, which is their kind of like proving ground for third-party libraries that maybe will eventually make it into the core tool chain, but they don't have it. So like that's a situation where I'll like make a concession and say, okay, fine, I'll use a dependency there.
Yeah, totally fair.
Yeah,
that's still a little more reasonable to leave out than hack leaving out like vec and dict from the standard library.
How is that now? Is it actually available? Because like I actually don't like I would have written more like one-off scripts in hack had there been like things like vect and dict like available in like I didn't have to like write a whole what's the dependency management thing for PHP that we have to use?
Composer.
Yeah, I just don't want to bother with it. You know what I mean?
Yeah, the fact that you have to like run a PHP 5 dependency manager to actually get hacklang working is nonsense.
Yeah.
I think it's going away. I hope it's going away.
Yeah.
Maybe it's just wishful.
Yeah. I would love to catch up with you on the latest goings on in Slack, now Salesforce, but we can save that for a later time.
For sure. Yeah, we got a bingo to play.
Nice. Okay. So what we're doing here is we're getting the input, which is a string. The string has a utility function called lines, which basically uses whatever new line delimiter is platform specific, and then turns it into an iterator over lines. I decided that like just looping over an iterator might be a little bit tricky because like this is heterogeneous data in here. So I thought maybe it'd be easier to deal with this as like an actual vector that is indexable. And maybe even like subdividable so that I can sort of treat the first couple lines differently than the remaining lines. Or I can say, I want to split this into like every 5 lines into like a little chunk, right? Something like that.
Yeah, just like shift off the first and then grab every 6 lines and discard the empty one or something.
Exactly, yeah. So what I did here is I collected it into a vector of string slices or references to strings. The collect function is neat because what it does is it takes an iterator and then creates a data structure for you to contain it. And that data structure could be a map or it could be a set. What's going on here is that there's a fair amount of like symbolic algebra in the Rust compiler, so it's probably similar to like a Haskell or like an ML or OCaml, right? Like it can kind of like, or even TypeScript, right? It can kind of just like infer what you're talking about by the types that are surrounding it, right? And because I added a type annotation to Sorry, I realize this text is probably very small, so I'm going to blow it up.
Oh, no, totally fine. I got a big screen over here.
Okay. I'm going to blow it up just I think it's probably better to be like slightly larger anyways. But you let me know if things aren't clear or if I'm talking too quickly.
No.
Because I added a type annotation here explicitly, you don't have to. Like, for example, this like let input here, it doesn't actually have an annotation. Like this like colon string here is just the language server giving me some bonus annotation visually. But this is actually explicit code that I typed in.
Yeah, and input is also a string, but collect could be a few things.
Yeah, and collect basically is able to say, okay, I think I know what you're talking about. You want a vector of strings. Now what I can do is omit it here and do a generic specification like this, right?
Okay.
The generic specification in Rust requires you to add this colon. Most languages you would expect it just to be this. But it turns out that in most languages, when you write the parser, generics that use angle brackets, so basically since C++, have always had super complicated parsers because it doesn't know how to differentiate between like an expression like this and an expression like X is less than Y is less than Z or something like that, right? Like it doesn't know how to like literally like greater than and less than like the binary operators like interfere with the generic parsing syntax. So Rust's solution to that was to create this operator, which is like colon, open angle bracket, close angle bracket, which if you just type it out like this, looks like that. And what they are calling this operator is the turbo fish, because I guess it looks like a little fish with some like motion lines behind it.
I can see it. I was thinking like a four-eyed duck.
Yes, I think I like that better, like a Cthulhu duck or something like that, or a spider duck. I don't know if you've been following the Go language, but they were so vexed by this parsing problem, and they're so diehard about making the parser simple. Which I actually respect over time, like grudgingly, that they decided that their generic separator would be like square brackets.
All right.
So that's definitely a choice, right? Anyways, enough about parsing. We'll go ahead and just like you can usually omit the turbofish just by like doing the thing that I did here, right? Which is nice.
Yeah, it's more straightforward.
Yeah, and then what I'm doing is I'm doing a split at here. Which basically is giving you like this is actually like one contiguous piece of memory, this vector here, and what I actually want are two separate things that I can manipulate independently. So I'm just doing a split at, and I'm giving it the index where the second vector will start. Right. So I basically just got like a slice of string slices called first, and another slice of string slices called rest. And this is how I'm essentially shifting off the front. I guess technically I could start at index 2, right? Because the input for the actual real stuff is starting here, right? So maybe we'll do it like that. All right, let's go ahead and parse the first line. So what we can do is, I think we can do like first.split on... Oh, this splits using a function. I think I have to convert this back to a. I think I'm just taking the first one and then splitting it. The pattern can be a string, a char. So we're splitting by, I guess, commas, right? And we're gonna get some num string, right? And what we want to actually do is fold this into. We just want to convert this into like just a vector of numbers, something like that. I'm just gonna call it numbers for now, and we're hoping that this is a vector of ints. And maybe we can actually just use sort of like a Rubyism. There's a lot of Ruby in Rust, so maybe that'll make you happy.
Absolutely. Ruby remains the best.
It's been a while for me using Ruby. So we can map over this, and we're going to get some string. And I believe we can just do parse on that and then collect again, and that should just work. Is it having a hard time with this? Oh, we need to unwrap the parse. Okay. All right, so just explaining what's going on here. We're taking the first element of this first array, which is really just the first line of the input, right? We're splitting it by commas, which is going to give us essentially an iterator over a bunch of string slices. So this 1 followed by an 8 will be one string slice. This 9 followed by a 9 will be another string slice, and so on and so forth. And then what we're doing is we're parsing it. And how we're parsing it is, again, one of those like the compiler is inferring that you're talking about I64. It just knows. Otherwise, we could use the turbofish pattern and say, like, we're parsing for I64. That, fortunately, comes from the standard library. I don't have to write that code. The parse may or may not fail, right? Like, if there's a number that, like, doesn't... Like, if it's not a number, if it's just, like, the letter C or something like that, it's just not going to parse into a number. So it might fail. And so what's being returned here is a result. You're going to be familiar with this pattern because we do that. We used to do that at Slack, right? And unwrap is just saying, I am asserting that it is correct. And I don't want you to return a result. I just want you to return the success value. And if it isn't a success value, if it's not a successful value, if it's an error result, it will panic. It'll just basically crash the entire program, right? There are no exceptions per se. Like Rust does not have an exception model. Like most errors are returned using this kind of result pattern. And then we're collecting it again.
They just omit exceptions completely from the language.
Can you say that one more time?
They just omit exceptions completely from the language. You get to either have a result or a panic.
Yeah, that's right. Yeah.
Cool. Hardcore.
In that regard, I think it's similar to Go, or just straight up C. Yeah. Okay, so we successfully have parsed the first thing, and now I think we have a trickier parsing problem. Let me actually just print out what we've parsed. And we'll go from there. It's saying that I have an issue. Oh, this is just, the issue is that I have an unused variable. Hopefully it won't crash. Okay, I think we parsed it correctly. Do you see this down here? It's a little bit hard. It's hard to see, but
yep,
hopefully that's visible. Okay. All right, so now we want to parse these things. So what I think I want to do is just subdivide these into chunks of 6, right? And then go from there.
Mm-hmm. Yeah, to get a board at a time.
Yeah. So, like, this is where like some languages will just give you like I want to like essentially subdivide this array into like subarrays of this value of this length. I don't know if Rust has anything like that. I think we can poke around a little bit to see if there's anything available to us. The Rust, I guess it's going to be like an enumerator or an iterator. Is there a way to chunk things up? And Arisa Snowbell, it seems like you're a Rust expert in the chat. If you're still around, you can let me know if there's anything easy.
Maybe take will take a number.
Let's see. Take yields first n elements. I guess we can iterate and just keep doing take. Oh, partition. This sounds pretty promising, doesn't it?
That might do, yeah, that's like a true or false pattern of like, give me the odd ones with the even ones.
Oh, okay, I see. Oh, I see. That's not 100% what I'm talking about, right? What is the word for this in Ruby? I think Python has this as well.
What was in Ruby? It might have been take or a synonym. There are always like 3 ways to refer to something.
Yeah, right.
Or I would just, for I from 0 to length, like I plus 6. And take slices.
Yeah, I mean, we could just write this ourselves, right? We could do like a reduce or a map on this or something like that.
I know it was Ruby. Actually, I don't remember if this was Ruby or maybe active support, or maybe it moved from active support into Ruby.
Mm-hmm.
But there was groups of. You could say array in groups of 5.
Yes. Yeah, it might have been like one of those like Rails things, right? Like Rails adds it for you. Yeah. Okay. I think maybe we just write it ourselves, right? It's a good little exercise. right? So I guess what we can do is, well, we can write, if we write it ourselves, it's just going to be like a literal like brute force kind of thing, right? So what we'll have is we'll just have like we'll have boards here, and that's going to be a vector of something that we don't know yet. Like we can make a board over here that just doesn't have anything in there, right? But we can make a structure of them. This is how you construct a new vector. Just do vec new. And then we'll just like literally just iterate over our lines, like for line in rest.iterator. So this is like this complex reference to a string slice. Like Rust does some like automatic dereferencing for you. But sometimes it's not super clean. It's a lot like there's enough magic and complexity in the Rust compiler that I'm not super confident in saying exactly what it does. But like, for example, I can do str dot and then call methods on it as if this was like a direct reference, but somehow it's like automatically adding like a dereference, like a 2 layers of dereferencing for me.
Oh, geez. That sounds more confusing than just making the arrow.
I concur. Yeah, I can also like pre-dereference it by adding an asterisk there, which is also confusing. Yeah. Okay. So what's the right way to do this? Is it better that we just actually iterate over indices? Because then we can do math, right?
Well, so what's our end result here is going to be like a board is a 5 long vector of vectors that are also 5 long containing numbers.
Yeah, we could do it that way. We could do one array of 25 if we wanted to be obtuse about it.
That's true. Actually, that might be easier. Well, depending how you want to check the board ultimately for rows and columns.
Yeah.
Like a vec of vex is basically the same iteration. Like you check any group of 5 and then any mod of a number, like mod 5 plus n.
Right. Yeah, so we could do it anyway. Maybe it's just like easier to just do the array. So why don't we just define it as that for now? So let's just call it like...
It seems harder to parse than do modular arithmetic.
This, I agree with you. So this is basically an array of like a 25 long array. I believe that's the notation.
Looks reasonable to me.
Yeah, it's complaining.
From C 15 years ago.
Let's see. Rust declare array. This is my level of Rust understanding right now. It was like I don't even know how to declare like a fixed size array. Oh, I see. It's this thing. There's enough that's unconventional about it that like it's easy to forget, because I've been bouncing between like TypeScript and C# and previously Hack, and it's just like too many languages. You know what I mean?
Because you do know in C#, right?
Unity is in C#, and we've been doing a fair amount of Unity recently. So yeah.
Cool.
Elements, we never read the field, and it's complaining. And then we can actually declare implementations for board, right? We can actually declare methods on board by doing this.
Interesting. Does Rust have classes as separate from struct plus implementation, or is
it does not? It does not. So you just have like, I'm going to write an implementation for board, and Rust also has this notion of traits, which allows you to write. You can almost think of like a module mix-in or mix-in in Ruby, where you essentially write an interface and declare constraints on what types this interface can be attached to. But you can do monkey patching this way in Rust, where you just basically say, I'm going to make an implementation for this new trait that I created for my program, but attach it to a built-in type. So for example, like this capital S string. You can simply by importing other people's third-party libraries extend the interface of the string object, of the string type, so that you can basically call additional customized dot functions on it, which is nice, right?
Interesting.
Yeah.
Huh. That's kind of surprising to me, given how strict a lot of the other stuff is being.
Yeah. it is surprising, but I guess essentially it allows you to, I guess, extend the type. Because this is statically compiled, what it's really doing, I think, is just allowing you to, like, rather than write a function where the first argument you pass in is the this object, it allows you to just, like, do a, like, this dot function name, right? Something like that. Yeah. And in fact, the way that you would write a function here is you'd say, like, function foobar, the first thing you pass in is a self, right? And that self is essentially referring to an instance of board. Yeah.
Okay, interesting.
Yeah. So if we wanted to be clever, we could, like, write an implementation here that, like, did our, like, am I a winner or not, right? And I don't know if this board will be mutable yet. Like we may want to, like, keep track of the state of the numbers that have been already called or marked off, you know? Maybe in like a hash set or something like that. That might be an interesting way of doing it. Okay, so I do wonder if it's easier for us to iterate over these things just simply by index, right? So something like I in 0 to the number of lines. Actually, it's rest.length. And the reason why I'm saying this is that, like, essentially what we'll know is, like, if I is a multiple of 1, 2, 3, 4, or 5, we'll know that we'll be here, right? And if it's a multiple of 6, this actually almost makes me want to just do, like, a regular for loop where I can modify the iterator number itself, right?
Yeah, or even go with, like, a repeated split at or something, just to, like, shift off and consume as we go. Sounds much simpler than like keeping multiples.
Like this split at here. Yeah. Let's give that a shot. So I think this is there a while?
I sure hope so.
Yeah. Loop while true. Just gonna do my kind of like classic infinite loop, and we'll figure out what the actual loop condition is gonna be here. What's it complaining about? Do you know? Oh, it's just loop. Oh, that's nice. Yeah. And I guess first and rest need to be mutable, right?
Yep.
Although technically,
Does split out return new copies?
Split does not return new copies. No, it's references to the same locations in memory.
Got it.
I think I'm just gonna call this like let mute A, mute B. What exactly is A? It is one of these things, like a reference to a reference of strings.
Yeah, the type should be the same throughout.
Yeah. And then what we're saying is like A and B are equal to, I guess what we're saying is B is equal to rest.
Mm-hmm.
Rest.split at, and what are we actually splitting at? We're splitting at 6?
Yeah, to get to the beginning of the next board.
Yeah. What's it complaining about here? Destruction assignments are unstable.
That's okay. Programmers are unstable.
Cannot assign in this expression. Luckily, it does give me this fun little thing I can click on to read. Sorry, I have like multiple browsers for multiple use cases here, so I'm just jumping back and forth. An unstable feature was used. I mean, if I wanted to get around this, I can just do like a super brute force thing where it's like,
Wait, so why is this any different than the destructuring split at on line 10?
Because I think it's the difference between like creating new declaring new variables and not declaring new variables, right? So I could do a vals.0, b equals vals.1.
Oh no,
and
it does
that
indexing
doesn't
with
complain about it.
dots.
Yeah. Yeah. I mean, I might be using an older version of the Rust compiler. Like Rust is moving pretty quickly these days. So for now, I'm just gonna like. This is not very clean code. It's not super idiomatic, I think, at this point. But maybe we'll develop that skill over the course of the month, only to forget it come December 25th. Right?
Wait, so now I have a question just about array indexing. If you do like vals.0, how do you do vals dot variable index?
So what we're looking at here, that's a great question. What we're looking vals is actually not a array, it is a tuple. So the length of it is statically determined. Right. And so
But
split
still,
out.
are you allowed to index tuples with a variable, or do you have to be totally static about it?
I don't think you are. You might be able to convert a tuple into an iterator and then index over that. Right.
Okay. Yeah, fair enough.
Yeah, but it's very obtuse. This is almost as if we have a structure with anonymous properties. You can think of it that way. Think of it almost like a struct that has a property called 0 and a property called 1.
Okay, that's fair.
Yep.
Totally fair.
Okay. All right. So now we can just parse A, right? And then so what we're gonna do is we're just gonna go from from 0 to 5. A of I split on commas, right?
Mm-hmm.
And that's going to give us a bunch of numbers. It's like a number string. We need to parse that, and then we need to chuck it into our board with some offset, right?
Yep.
And we probably want an index from this as well, right? We want to know, like, we actually probably want to, like, we want to know, like, a J, like how far into this particular row, like what column on the row we're at, basically. And
Hey, what if we join these 5 lines into one line, and then we'll just have 0 through 24 like our board has?
okay, we can totally do that. So what you're saying is,
Like replace new line with comma. Or we already have arrays.
we already have a vector of vectors. So I think that's a good idea had we kept this into one thing.
Like
Yeah.
like if we hadn't already called lines on the input.
Yeah. Unfortunately, we do because we had to call lines because we just needed to be able to like split things up into chunks. But I think that would be a good idea had we gone about this like a slightly different way for the beginning.
Oh, yeah, let's stick with INJ then.
Okay. All right. So I think we need to create a new board, right? So we have a vector of boards. Let board. I don't want to heap allocate this. I think that's what this will do. Oh, wait. I don't even have a new function. I think I can just make a board. Like, how do I, again, like, it's like, how do I statically declare a board? Rust. Statically declare struct. Oh, that's cool. This is actually the exact syntax I would have wanted it to be.
Nice.
In C#, it's just like this incredibly obtuse thing where it's like new board, parentheses, even if it's stack allocated, you still call new, you still call a constructor. And then like prop equals prop val. And so my brain is just total mush at this point in terms of just different languages, the way this works. So, but what I can do here is I think this is just it, right? I think like I could just do new board, and I'm just hoping it'll be happy. Missing elements. I think I actually have to declare this, and I just want to say that's like a bunch of zeros, and there's 25 of them. Is that gonna be sad? Okay, it's satisfied.
Oh, cool. That's nice syntax for like filling in.
Awesome. We got another person in the chat room who has a totally unpronounceable Discord name, D4D I would almost think that they're a spammer, but they're saying yo Rust is fun. So
Could still be a spammer.
They might be a Rust enthusiastic spammer. But you know what? I'm grateful for you joining. We were not discriminating against spammers today. Not today.
Absolutely not, especially spammers as smart as to decide to spam about Rust.
Yeah, they might actually be really good, right? So am I iterating over the right thing? I am iterating over A correctly, right? And so what I actually want to do is I just want to say that my board at element I times 5 plus j equals the number string, but that I'm parsing into an I64 and unwrapping it. I think that's what it is. And then it's actually board.elements.
Or right? Is it?
It's not mutable. I need to declare this thing as mutable.
Oh, fair enough.
Yeah. Believe it or not, all this like mutability stuff, it's a pain in the ass right now because I just don't remember how to do any of it. But it actually does prevent mistakes. And I think what you'll hear from like people who do work with like super type strict languages, you're familiar with Haskell and that kind of thing, but people will say that like you write your code and once you satisfy the compiler, the program more often than not just works. Yeah.
Yep. I completely believe that.
Yeah.
We're catching compile time bugs instead of runtime bugs.
Yeah.
Which is substantially easier and faster.
Yep.
I had a coworker who once did Ludum Dare, the like 48-hour game challenge.
Yeah.
I forget how long it is. He did it in Haskell, and when he showed it was early. When he showed the code to the judges, they said like he had to write an actual program. He's like, I did. Like, this is called Haskell. And they thought that he had just written pseudocode. They're like, you have to like write something, man.
Oh, but he did have a game to like show them, right? Like at the end. What? I'm surprised that they were looking at the code.
That's fair. Oh, maybe it wasn't Ludum Dare. He did a bunch of Ludum Dares, but maybe it was like a different coding challenge.
Oh, right. Yeah. But Haskell does have that feeling of like I've written not only pseudocode, but like the math version of pseudocode. You know what I mean? You know what I mean? Okay, so I think we have successfully done this, but the problem is we don't have a loop termination condition, and is it B is never read? I think it's B that we wanted to do here, right? So how do we know if we're done? B should be empty, right? Or the length should be less than 6, something like that.
Actually,
right?
Yeah. Here's my question. So the last board in the file might not have an empty line after it, and maybe the answer is put an empty line there so that we don't have to worry about it. But if we index a 5 long thing with 6, is it gonna give us 5 and empty, or is it gonna yell?
That's a great thing to point out. We're not indexing with 6 right now. 0.5. I don't know if Ruby does this notation, but there's like the difference between ... and ...
Yeah, and Ruby does it backwards, and it drives me crazy.
Okay.
The third dot means one less element. I think of it as the dot eating the last element. No, but I mean up on line 18 where we're saying split at 6. Like if we're out of bounds, is that an error or is it just emptiness?
That is a great question. Right, because when we get to the last thing, it's probably going to be out of bounds, I'm going to say. Right.
Yep.
We could be super cheesy about it, and God, we could assign like we could do something like if b.len less than 6, then we just say that a is equal to b.
Nah, that's gross. I
agree.
The clean cheesy. Well, first of all, I'm curious. Like we can run this and see. I'm curious. Like our exit condition, if we throw it in as like b being empty, we'll see if it crashes or not. The clean cheesy thing to do is add a new line to the end of input so that we always have a multiple 6.
We can definitely do that. So the thing that we can actually modify is the vector. Once we've done split at here, we no longer have vectors. We have like slices, and slices are not. You can't add to this. It's no longer like a structure that has a buffer and knows how to like copy stuff over into a new buffer if you extend it, right? That's what vectors do for you, right? And then like this slice does not have that capability. So if we wanted to add stuff to it, the site to do it is here.
You misunderstand me, sir. I meant the input.txt file.
Oh, this one here.
No. The data file.
Oh, okay, yeah, that's a great question. The one thing I don't know is whether lines will omit that empty line or not, but we can test that really
Ooh,
easily.
fair.
Yeah.
I would be pretty angry if it did. Like, what if my entire like data schema is based on how many empty lines there are at the end of my file?
Well, let's check it out, and then we'll return early. Da, da, da. Is it complaining about unreachable statements?
Cool.
Oh, it can't be formatted. So you'll notice that when I was doing printlns, I was adding this like inscrutable like thing here. Like I'm okay using this as like kind of a marker. I think xargs kind of conventionally uses this. Also C# string interpolation does this. I have learned in the last couple months. But I have to add this little extra demarcation here. If the object that I'm trying to print does not have a toString function. And vectors do not have a toString. However, vectors have like a debug print. And so basically this says like, instead of calling the toString on the thing I'm passing in, call the debug print thing.
Oh, Jesus.
Yeah, okay.
Why not just let it be a string and then call lines.debug print?
All right, well, Kristjan, this is going to make you angry. There's no new line on that.
Oh, they ate it? No,
They
that's
ate it.
so rude.
But what we can do is do lines append.
Wait, did Rust eat it, or when you saved the file, do you have a setting to clear empty strings at the end?
I believe the file has an actual string here. Has an actual empty line here.
All right, well, now I'm never using Rust.
All right. Oh, you know what? This is like string. It's like, how do I actually convert this? I think there's like a from string. Again, there's like a difference between a heap allocated thing and a. Why is it having a hard time appending? Lines is just a vector. Oh, append is appending. This is not. It's add or push. I think. Oh, gosh, push is just like a terrible name. And now I have to make this mutable. I wish there was a way in a language to say like, okay, after this line, this variable is no longer mutable, right?
Yeah, like, or maybe as part of the variable initialization, like give it a little semi-constructor block of like stuff I want to do to it before it's declared mutable.
Yeah, totally.
Yeah,
I guess I could
could
reassign. I could just call it like let lines equals lines, you know, and it's no longer mutable. Like it's really kind of
really?
Yeah.
Oh, interesting. Wait, I'm surprised it even lets you use let with a thing you've already declared.
Yeah. Okay, so let's try running this again and seeing what happens. And we've got our like empty line at the end there. So this makes Kristjan a little bit happier, I think.
And the other thing I noticed while you were wrestling with that is we don't need to split our numbers on commas. We need to split on white space, and it's justified. So it might be 1 or 2 spaces.
Okay. That's
Ooh, in
horrible.
fact, we can't even split because one of the things in there was space 1 at the very beginning of the line. So I don't know how split works in Rust, but that might give us an empty element.
Yeah, you're right. I don't think that there might be a split on pattern that allows us to specify multiple. This pattern can be a string, a char, a slice of chars, or function or closure that determines if a character matches. But this is only splitting on individual characters, basically. If we were using like another language like JavaScript, you could split on a regex, which allows us to do multiples. Like, but maybe there's a way.
A regex isn't even in the standard, so we can't.
Rust, split on any white space. There is a split whitespace function. Hey. Oh, this is an experimental only. Oh wait, no, this is no, it might exist.
Is there a scanf equivalent? Because the other thing we could do is just say, give me 3 characters and then parse them as an int.
It's funny that you mentioned that. Because when I was doing this in OCaml, I just used scanf, and I was happy as a clam. It like takes care of like 99% of all the parsing needs that you have.
Yep.
But there is not.
Okay, then is there
split ASCII whitespace? Hell yes. All right, we're in business here. Yeah.
Cool. But we need to deal with stuff at the beginning of the line, with white space at the beginning. So is there a trim?
That's a great question. There's a trim.
Yay!
And it just works. I'm just trusting I'm trusting the analyzer here to tell me that it's working. Real quick, Ariza Snowbell in the chat is saying indexing with square brackets basically crashes the Rust program. It is better to use the get function, which returns an enum option, which is like kind of like a like a result value. Did it succeed? Did it fail? I think that's good practice in general. In this case, I want it to crash, right? Because I don't really have anything I'm going to do with an out of bounds index other than to just say that you did it wrong. I guess I could give it a better error message, but I trust the runtime to give me something that's like, hey, at least it failed on line 27, right?
Yeah, well, and if this were like a production environment where we don't know stuff about our data file, then like absolutely,
Yeah.
and we need to report back to the user that this was a bad upload. But in this case, we know the data file is the gold standard, and so that means the problem's in the code.
Yeah, totally. Yeah. So board.push board. They had an opportunity with the new language to not call a vector, right? Because like a vector's, there's like already like a math meaning for a vector, right? Like if you're gonna make a new language, just call it
like list.
Array list is like what the Javas and C# of the world call it.
Yeah, but array and list like kind of mean the same thing. That word has always felt redundant to me.
Yeah, I suppose list can mean linked list. I actually think in C# they just call it a list. I think list is fine. Or like some kind like like growable array or like I don't know vec. I guess it's 3 letters that has that going for it. I don't know if push is excusable though. Push has always like been like this kind of thing that's just been around, and of course we're used to it because I think JavaScript and Ruby just call it push. Maybe C#'s vector library calls it push too. I don't know.
I always got the sense that push and pop were, I mean, they're stack operations, which is mixing another concept in to our list.
It's true, yes, you're right.
I always feel like they go all the way back to like bash. Like I guess bash mostly does shift, but does bash do push?
I bet there's push.
They have push D and pop D for directories, so at least it's nearby.
Yeah. Rust has a really nice standard library structure called the double-ended queue, which is totally unspellable. It's like DEQUE. Like it's just like I have to remember how to do this every single time.
I always called this a deck.
A deck.
And I don't know if anybody else does.
Yeah, a deck. And so they have push front, push back, pop front, pop back, which is a really nice API, I think.
Yeah, that's nice and clear, as opposed to like push and pop from one side, shift and unshift from the other.
Yeah, I don't even know what the thing is for like the front in Rust. I don't know if they do shift. I think it's just remove at. Okay. It's like remove 0.
That's fair. That's cool too.
Something like that. Which theoretically we could be doing here. We're just using all these things that are just digging us deeper into the borrow checker hole, but whatever.
Yep. I'm just happy that it's push and not index with an empty, index with nothing, and like ta-da, that'll append a value.
Yeah. Okay. So why don't we just see if we're parsing our boards correctly? And I think in order to debug print our boards, we actually need to add some stuff up here. Derive. This is how you do kind of like. It's not a preprocessor, but this is how you do annotations. Debug clone copy. These are things that you'll derive like very, very frequently. And what derive is doing is it's saying, okay, the standard library has a bunch of traits that it knows how to code gen traits for just generic structures. And what this is actually doing in the background is it's creating impl debug for board. It's doing that monkey patching thing that I was talking to you about before. And it's just spitting out code that knows how to do a default like debug print. I don't know if that's the actual name of the function of a structure, and it knows because this is it's in compiler land. It knows how to like reflect on the type here, right? I don't think there's any runtime type reflection in Rust because Rust is basically C, right? There's not like a heavyweight runtime, so it doesn't have like a giant table at runtime of like what the types look like. But at compile time, it does know. So it can do all this stuff like say like, okay, just iterate over all the properties and then call the debug print of every single property inside of it recursively. Something like that, right? And then clone and copy similarly is saying, okay, I'm going to impl the clone clone trait for board and write the clone function and also write the copy function. And what clone and copy allow us to do is to essentially make the struct like basically like a pass by value, assign by value structure.
Okay.
So if I do a push, yeah, go ahead.
What does clone do versus copy?
Yeah. So clone just basically says, it implements the clone function. So that's similar in Ruby where you can just do object.clone. Mm-hmm. With copy, what you're saying is that actually when you do an assignment, and that includes passing it as a variable as an argument into a function, you're passing a copy of that instead of a reference to it. Yeah.
So deriving copy changes it from pass by reference to pass by value.
That's correct.
That's fascinating. That feels like such a language/compiler level thing.
Yes. I agree with you, but copy, they've managed to make it into a trait. And anything that's in a trait is technically like userland implementable. Mm-hmm. And so what's interesting about this is that I think if this wasn't copy, I'm actually surprised that this compiles. Because what we're doing is we're pushing board. You know what it is? It's fine. Because what we're doing is we're doing a move. Board technically is short-lived, and we're pushing it into this array. But then what we're saying is that this version of board is just being moved into the array and just basically doesn't exist anymore. So if this wasn't copy, I think technically after line 33 here, if you tried to reference board, it would say, hey, you can't use that variable anymore because it got moved into the vector. Yeah. And this is them trying to say, like, you can't have two variables pointing at the same thing, or else, you might have spooky action at a distance at that point, right? You might like modify the variable in one location. They're trying to prevent aliasing, basically, is what we're talking about here, if that makes sense.
That's pretty cool.
Yeah. I don't know if board needs to be copy right now, so let's just, but it doesn't matter if it is or it isn't, so I'm just going to add it here. This will just like save us some pain in the future.
Feels safe.
Yeah.
And then you can still pass by reference if you want to, if you just put an ampersand in front, right?
Correct. That's exactly right. Yeah, you're getting the hang of this stuff. All right. Okay, so we don't have an exit condition here. So what should our exit condition be? Is it that B's length is greater than 0?
Yes.
All right. So hopefully this won't infinite loop. Okay, that looks pretty good, right? Is 83, 57, 21 the last thing in our file? It is. And then let's also check the first thing, 12, 79, 33. All right. So we have, after much ado, successfully parsed the input of an advent of code.
It took us an hour.
You know what?
We're 3 minutes. I'm just going to go do
there's a bit of a blind leading the blind action here going on. So I think it's pretty good. It's not too bad.
I appreciate the language education too.
Yeah, I appreciate it as well. I very much appreciate it. So okay, we actually have to write our simulation. So I imagine what's going to happen is we're going to be like for num in numbers. Right? We're just going to be iterating over these numbers that we just parsed out painstakingly, right? Excuse me. And then we're going to be running a simulation where we have to iterate over our boards and maybe say, this board's... I guess we just want to keep track of the numbers that have already been called, right?
Yep. Yeah. So we can either keep track or we can go and like destruct the elements in our list.
We do need to keep the geometry though, right? We need to know whether rows or columns have been like, what's the row and column relationship between those numbers, right?
Yeah. No. So we're not going to like change the length or anything. What I'm thinking is like when we ultimately do our check for like is a row full or is a column full, like how are we going to notice? And it feels potentially easy. Like if we, if the number 17 is called, if we go and replace the number 17 in our list with a 0, assuming a 0 can't be called or a -1 or something.
Yeah, I don't think 0 exists. Oh, 0 does exist. So maybe
a -1 won't.
Yeah, a -1 won't. Yeah.
Because then we can just look at like, okay, are these 5 -1? Are these 5 -1, etc.
Yeah, and then just ignore a -1, right? Is what you're saying.
Yeah. Because otherwise our checking loop is going to be like, I think at least O of n squared, because we're going to have to run through the numbers that have been called again.
That's exactly right. So you're basically saying we should basically mark things off in the boards as we go ahead, or else we're just going to have to like loop over every element of every board every time we check.
Yeah.
So we're doing a little cache basically.
Here's another dumb idea.
Yes.
We could keep our list of marked coordinates. Like if we like a hash table of row 1, row 2, row 3, or column 1, column 2, column 3.
Yeah.
And given what index we find a number in, we like increment our rows and our columns, and then we're just done when one of those gets to 5.
Yeah, I like both of those. I think the -1 might be simpler to work with up front. We'll see if it bites us in the ass either this problem or next. So let's start with that one. Another way that like Rust lets you be like super explicit about stuff like this is you can do like enum like cell, and you can say marked or value with like an I64 in there, and you could actually make your thing like a cell of these things, right? It does enums that have they're I guess tagged enums. Is that what they call this? Where you can actually have values inside the enum option. And this is like my favorite thing about Rust, is that you can have like really explicit state conditions, but those conditions can also have some variability in them as well, which is great.
Yeah, that's very cool.
Yeah. I think we can afford to be a little bit dirty and just do -1 for now, if that's cool with you, which I hope it is.
Totally.
Okay, so we're iterating over the numbers, and I guess what we're doing is, first of all, we'll just go through all of our boards.
Oh, just thinking forward again to our like the last number we need to generate when we multiply everything. That's only the numbers that we haven't marked, right? So we're not destroying that info.
Yes, we're not destroying that info.
Cool.
I think just by overriding the problem is designed such that like we don't care about the values that have already been called, right? Yep. At least on those boards. Yeah. So I think what you're saying is that we can do like b dot. Well, we have to iterate over all of the like elements, right? For I in b dot 0 to b dot len.
So for sake of this for loop not getting for deep, this feels like a method we should write on board.
Yeah, we can totally do that. Yep. It would have taken me probably like another hour of programming before I like I had my like cumbersome 6-level deep iteration before I had the wherewithal to do this. So are we just doing like we're just gonna call it mark?
Yeah.
Okay, and then we're just gonna do for I val for let's just do for I in 0 to the number of actually, I think we need to pass the self in here. And it's got to be a mutable self, right? Because we're changing self. Self.elements.length.
Are we changing self or are we changing elements? Or I guess by nature, changing elements, we're changing self.
So that's exactly right. Yeah.
Okay.
Oh, yeah. I'm just moving in between too many different languages. The annotation goes on the back. What we're saying is if self.elements I is equal to val, then self.elements I equals -1, and we're done, right?
Yeah, there are no duplicates, right?
There are no duplicates on board.
Bingo card.
Yes. I'm pretty sure that's the case in bingo, or else that would be a huge advantage in playing the game, right?
Yeah, it doesn't really make any sense to the rules.
Yeah. Okay, so what we're doing is we're going through all of our boards and we're marking them, right? b.mark num. And this is complaining because I have a reference to I64 when I want to pass an actual value. So I needed to...
Wait, so it'll if you call like, stir dot whatever above, it'll double dereference for you, but if you want to pass one, it won't.
Yeah, it's not my favorite part of the language, but I think they had to pick the lesser of two evils because a lot of what Rust is about is like creating these like giant dot chains. There's a bunch of Ruby people like Yehuda Katz and Steve Klabnik that were involved in the development of the language, right? And so they have a aesthetic preference for doing like dot chain stuff. And when you pass, like you usually have like a block or a lambda that you're passing into these dot functions to do like processing, like a closure. And that has to be a reference because like Rust is intending to replace C. It doesn't want to like make a copy for you automatically, right? It wants you to be explicit about that. So it's passing like a bunch of references into things. And so probably before they had all of these ergonomics that automatically do reference for you, they were just like having to like add like 3 asterisks to things, and it was just getting cumbersome.
All right.
So yeah, I don't know. But the end result is I don't know how to explain the rules to you, right? And the communication about the language becomes hard. And that is the knock on it. It's just really, really difficult to know. Now, okay, here's a question for you. If we're going to iterate over potentially the entire length of the board to mark it, should we also just be checking to see if we've got you know what? I'm not trying to be too optimal right now. Let's just like write another function that says, do I have a winner in me or not?
Yeah, that feels better to me. And especially because I mean, what are we going to do? Like throw an exception?
Yeah, right.
Or I guess Mark could return a Boolean of like true or false. We won.
Yeah, that's a lot of extra work in there because like honestly, we're not like if we do a loop over the elements twice, it's not like big O worse than looping over it once, right?
Yeah, and there are like 100 boards in the file or whatever. Like that's not going to be a problem. We're being plenty efficient. We just need to like the brute force we're avoiding is that last multiplicative number.
Yeah. Okay, so has one. So what we're doing is we're just looking for either a row of -1s or a column of -1s. Is that right?
Yes.
So this is the row loop.
Yep. We could even call these row and call.
Check row winners. We can call them row and call. I'm so used to doing ing as row and call, but you know what? Why be obtuse, right?
Well, so the reason Advent code is actually the thing that built my habit of calling things row and call, because when you have doubly nested arrays and you're representing a Cartesian XY plane, you quickly get upside down. So I just got in the habit whenever I have something boardish of like row and call.
I think that's totally fair. That's totally fair. Okay, so we're checking the row winner. So that means that if self.elements of row times 5 plus call is not equal to -1, we failed this row, right? So we need to go to the next row somehow.
Oh, cool. Yeah. So we can just break out of the column loop, right?
Yes, we break here.
Let's smooth. I was thinking we could like count from 0 to 5, but this is cleaner.
I actually kind of want to not only want to break out of this column loop, but I want to break out of the row loop as well and go to the next row. Because I think if we get down here, if we get here, we won, right? Is there a way we can do a double break, like a go-to or something like that?
We don't need to do a double break, do we? Because if it, oh yeah, so the row loop does need.
The other way we can do it is like
we stopped on.
We could just do like let
we could,
OK equals true, and then we can do OK equals false here, and then we can do an if OK.
Yep. Does so like in C, does the call variable persist after the loop, or does it?
It does. I don't think it does. Like if I just type call here, I'm not sure if it knows what it is. Yeah, it doesn't know.
Okay, that's because then we could have checked, is it 4 or 5?
Yeah. What is it? Oh, it's just complaining that let's just do return false down here just to get things. Now, just to satisfy my curiosity, I'm gonna see if there's a way to do like Rust loop level labels. Oh yeah, so we can do like something like if we wanted to be super rusty about it.
Whoa, that's extremely cool.
This has to be followed by a colon. And then we get rid of this. And then, yeah. This is actually the one place, like if I was in C, where I would use a goto, right? I would call this row and I'd go to row.
Mhm.
So, okay, this is our, this is checking for our row winners, and I think we have to do something similar, but we have to check the column winners, right?
Yep.
Um,
And this time it'll be, is it call times 5 plus row? Oh, that's all backwards.
I think it actually might still be the same thing, right?
It could be the same thing. Oh, but you inverted the loops, yeah.
Yeah, because we're basically going down the rows for this particular column, right?
Mm-hmm.
Feels like the same thing. Is that right?
Yep. Yeah, we've just transposed the loop, which is identical to transposing in the direction we're going on the board.
Okay. While we're here, we got to figure out the score, which is just a number, right? And then what we're gonna do is, we can here we'll do the fancy fold, and the score starts off at 0.
I'm so happy it labels the init value versus the iterator value.
You would not believe
every time I try to fold.
every single time. Like when I was doing this in OCaml, there are actually 2 different popular OCaml libraries. There's no real OCaml standard library, but there's like 2 that kind of like people compete against. There's the one that Jane Street publishes, which I think is called like Core, and then there's another one called Batteries, and they do the opposite ordering for their reduce fold. One of them uses, it's freaking horrible. But in this case, I think I think it's like, okay, so what we're doing is we're saying we're returning if val is greater than or equal to 0. We're returning a cum plus val. Otherwise, it's just a cum, right? That's accounting for our negative ones.
Yes. Is it a cum plus or a cum times?
In this case, I think we're summing. Let's go back. That's a great question. Start by finding the sum of all unmarked numbers on that board.
Cool.
And then we're multiplying by the number that was just called. So we will do a multiplication, just not here. Okay.
Okay. So we're going to need to pass in the most recently called number to this function too.
I think we can do it. Maybe let's not call the score. This is called the sum unmarked. How's that?
Sure. Yeah, we can, and then we can multiply in the top level. Yeah.
And it is. Oh, it's complaining about my semicolon. So if you don't put a semicolon at the end of a line, it'll assume that what you're trying to do is evaluate the entire block context that we're in, because Rust is technically expression language, not a statement language. That's why I can do in my closure, basically the return value of the closure is an if statement. And then the value of this whole branch of the if statement is just like this expression here. It's nice.
Yep. Here's a theory hole in my head. Is an expression a statement that yields a value? Like what's the difference there?
Statements are just like, statements actually have a value, which is the null value. Null value looks like this in Rust. And so this is an expression here, but if I didn't have a semicolon here, it would think that I'm trying to evaluate main as this thing, but then I've got more shit behind it, so it doesn't know what to do with the rest of this stuff, which is why it's giving me this little squiggle here.
Oh, okay. So if you omit a semicolon, you can only have a function.
Yeah, that's right.
You're saying like, here's what I am. Got it.
Yep.
Okay.
Yep.
That's a little weird syntax-wise, but sure. Like, why
not just force people to like type return? Yeah. Well, I mean, the thing is it's nice because like there's no ternary operator in Rust. This is your ternary, right? So at least for if statements, it allows you to have like a multi-statement if branch, but then evaluate it into a value that then the if can like essentially return. to an assignment on the left side,
I need to see like the talk about their philosophical choices because like okay, here's automatic dereferencing, but ternaries, no, that's too far.
Right. Yeah. I don't know what the ternary thing is. Maybe, well, the question mark has different semantics. Like there is a question mark operator. Like you can do this. Like if you have a result, you can do question mark here. And what that's the equivalent of is this like let res equals s dot parse, or it's actually like a match statement. You match this, and then if it's like a success or it's like an okay value, then do okay, and then if it's error, then do error, and I forgot where I was going with this whole thing.
What question mark is?
Yeah, question mark basically says that if it's an error, it's actually a return. It basically propagates it up this call stack for you automatically. That's what the question mark is. The question mark is equivalent to this whole giant block of code, which is nice, right? I mean, if you think about all the code that we wrote in Hack that uses this pattern, like every time you check, there's also like this if block afterwards, right?
Yeah, if error, return error.
And that's all that question mark is. And so the reason why I went down that rabbit hole is maybe the fact that they're using question mark there makes a traditional ternary hard to parse or something like that. I don't know.
Yep, sure does. Huh.
Just guessing.
Is there? Do they have an equivalent where like if there's an error, I don't want to return it. I would like to just have a null.
Yes, they do. I think that they call that.
Maybe or something.
It's like okay or yeah.
Okay, cool.
Yeah, Rust also has an optional type. I think they call it a maybe or an option that has a bunch of these. Like if it's okay, then do one thing. If it's not, do the other thing.
Yeah. Cool. Yeah, that makes sense to implement as a function, whereas like you really need the question mark syntax to imply a return.
Yeah, I think I'm because like Rust also borrows a lot from like OCaml, and OCaml has like a ton of like it's okay or call this function. It's okay or return this null. It's okay or throw an exception. Like it has a bunch of those like utility functions built in, right? Yeah. Okay, so I think we haven't run the program for a while, but like I guess the way that we test is to just like go for it and see what happens. So I guess each time we mark a board, we can just check it, right? If b dot has 1, we're kind of done, right? We can just like println b dot sum unmarked times the number that we just called, right? Which is num.
Yep. And
then we're done. And it's complaining because I keep adding parentheses when it doesn't need them.
Okay.
Which
is that a language thing or
that's a linter thing?
Okay. But have they like built the linter deeply into the language the way Go did?
That I don't know which linter is running because there's actually two different linters. I think the one that we just saw is the one that's built into the language, so you're getting a compiler warning there. And there's some style-oriented stuff in the compiler. There's another linter called Clippy. I think that was a very intentional choice of name. They're millennials that design this language. They have a fine sense of computer irony. But
well, of course they have irony. Their language is Rust.
Yeah, right. Do you know the Oxide Computer Company?
No.
That's where Brian Cantrell went after Joyent. He like just basically founded. They're basically just making servers, like data center servers. They just decided we're gonna make our own computers, which is as quixotic a startup idea as I can think of. But more power to them.
Like you know what we'd like to do? Compete against the world's entire installed Linux base.
Yeah, well, I mean, if you think about like what AWS is doing with like Graviton hardware now, it's kind of like a similar type thing. Only it's like we'll make a startup that does that, you know.
Okay, like here's something super specialized.
But what they're trying to do is they're trying to say like you should not run on cloud, you should run on-prem. which is again like very against the grain. Yeah, you should run on-prem. You should run the computers that we make on-prem. But they're called Oxide partly because they're writing all of their like microcontroller operating systems and stuff in Rust.
Mhm.
So
Cute.
Oxide is their. There's just so many good Rust puns, right? There's like an open source like firmware project called Coreboot, and then someone had someone had the idea that they wanted to write it in Rust. They called it Orboot, and it's like a triple entendre, right? Because it's or because it's Rust, but it's also Coreboot without the C because Coreboot is written in C. So like yeah, there's a lot of like good
Oh, wow.
punnery. Yeah.
Yeah, that's fantastic.
Okay, so Clippy, the linter actually does like multi-line analysis, right? I think the compiler will do like analysis at the level of single statements or single expressions, but like Clippy will say like, hey, you've done some like really weird shit, like in your entire for loop or your entire while loop, which is kind of amazing, right? They're doing like semantic analysis over whole programming patterns rather than just like single line things, which
That's
is
nice.
really, really nice.
Does Rust make like the AST available for them to do that, or are they doing something else?
Yeah, I think Rust has the AST available. What's nice is that the thing that's providing code intelligence in VS Code right now is a language server implementation that is called Rust Analyzer, and I'm pretty sure they're just plugging into the same libraries that the compiler is using.
Nice.
Yeah,
That's great.
it's always scary when like there's like a disconnect, right? Like someone just like writes a language server. Like if you think about it, like probably like JetBrains, that company that does IntelliJ, like their whole bread and butter is writing IDEs that have like really, really excellent refactoring tools and code intelligence, but they're not the ones that are developing the compiler. So everything that they write is probably like bespoke. You know what I mean?
Yep. Yeah, when LSP first appeared, like I don't know when, 10 years ago? Felt like 10 years ago to me.
Yeah.
I saw it, I was like, how has this like why didn't we do this 30 years ago? Why are we just thinking of this now?
Well, I don't know. Like, I don't think it was obvious to people that they wanted. You're right that it should be a 30-year-old thing because, like, if you think about it, like, everything in the 1970s, like early Unix, was a server, right? Or at least the 80s, right? Like who? It's still kind of beyond me that like X is a client-server protocol. Like you think like a GUI and like rendering Windows is like the most like local native thing that you would want, and like sticking like a network layer between all of your like mouse clicks feels like not the most efficient thing to do in the world. But they just like, no, we want a client and server,
But not in the 80s when I mean I don't know when X was built, but when your machines are all remote, right? You're in a terminal.
It's a dumb terminal philosophy, and if you think about it, that's where we're going back to for coding, right? Because
With that, like, I think of it more as the just like here's a level of abstraction thing of like we have myriad editors, we have myriad languages. We want to do the same thing in all of them, right? Which is like rename the function across the code base.
Yeah.
And so like back as far as like Smalltalk and earlier, like Next Step and whatever, like here's like some good object oriented stuff with interfaces. Like why didn't we apply this interface to everything?
Yeah. No, I totally know what you mean. I guess before it would just be like, well, we'll make it a library, and that you can include into your C build. You know what I mean? That's probably the extent of it. But yeah, I don't even think LSP is like a network protocol, right? I think you can just do it with standard input and standard output, right? Like your editor or whatever, or your client of it, just like runs the LSP server as a separate process and just streams in bytes.
Yep.
Through standard input. Yeah.
And then it could be local, it could be remote. Like nobody cares. It's just a stream.
Right. Okay, so I just ran this. It spit out a magic number. I'm not even going to try it with test input. We're just going to go for it. Okay, so it's not the right answer. We got nailed. Okay, so now tail between our legs. We have to just debug using their test input.
Yep.
Before I do that, any wild guesses as to where we went wrong?
No, I was pretty convinced. We're probably off by one somewhere.
You know what? I bet you're right.
Like we have enough for loops that it's almost certainly off by one.
Yeah, I'm gonna do one thing that I think is probably a little bit better is like I want to refer to our sentinel values directly. So I'm just gonna call it like -1, -1, -1. I don't think it matters. It's not the problem. I'm just gonna like make that quick edit. So I'm gonna go ahead and just like use their sample input real quick. And 4512. The worst, and this happens to me like 50% of the time when I get it wrong, is that like I'll plug in the sample input and it'll be fine. You know what I mean? Which means that there's some random, and that is the case for us today, right? There's some edge case. There's some edge case.
Wait. Look, I see a 0 value in one of these boards.
Okay.
No, the Sentinel change did it. Because you didn't run on the same code we ran the real input on.
But I had greater than or equal to 0 before, right? So we can try running our input again and seeing if it changed anything.
Wait, but was our Sentinel 0 or 1 before?
Our Sentinel was -1.
Okay.
I think Sentinel is like maybe the wrong word, but you know what I'm saying. Like some marker value, right?
Yeah, that's what a Sentinel is.
You know, I thought that, then I looked it up, and I think Sentinel is technically supposed to be like the marker at the end of a list of things. But you know what? We're communicating, you and I, right? We're making sense to each other. Okay, so when I ran it again with my code change on the real input, the value didn't change. So we have some subtle issue.
Yep.
That we're off by 1 on. Which is good.
I also wonder,
yes.
Like often when I screw these up, it's because I missed like a small detail in the instructions.
Okay.
Like what if 2 boards finish at once? Are we supposed to pick the bigger one?
Great question.
Or maybe they've said it. They've probably said it the inputs.
If they're not explicit about it, then I'm guessing that that the inputs are just designed just so, right?
Yeah, we often are.
Yeah. There are rare occasions where they'll say mea culpa, some of the input sets actually have a bug in it. And we'll like not count that day's score, right? But those days are few and far between, like once a year at most.
And probably not on day 4. That's when it gets more complicated.
Say what?
Probably not in day 4 either. Like that's when they screwed it because it was a more complicated problem.
I think they screwed up day 1 last year, but it was more like that was like an operations problem, right? It was like the server was down or something. Okay. At this point, the third board wins because it has at least one complete row or column of marked numbers. It could be that we're doing rows correctly but not columns correctly, right? Because like I think the row in this, the row is the winner, right?
Okay, yeah, it could be. That's good to check.
Yeah. So let's really interrogate this. So we're going first column first.
Yep.
And then we're iterating over every element vertically.
It's going to be 0. That'll be the 0th element.
I mean, that looks pretty good.
And then row will be 1. We'll get the 5th element.
Yeah.
Seems right. And then column becomes 1. We get the first element. Row becomes 1. We get the 6th element.
Yeah.
It seems fine to me.
My idea is to transpose these, but I don't trust myself to transpose it correctly. Do you know what I mean? Like, is there going to be a bug in the transposition code?
Right. Yeah, we're just introducing fog.
Yeah. How would we transpose if we wanted to?
Yeah, now I'm curious, like, how do we transpose a flat list? And it's going to be like we reverse, or no, not reverse.
Okay, I'm going to take your advice here, and then I'm going to just call these rows and columns as well. It's funny, all of my menus have this purple tint to them, and I think it's because I have Unity running in the background. Do I?
What?
Yeah. When you run, well, we have a thing in Unity where if you hit play in Unity and you're in play mode, we change the entire interface color just to know that you're in play mode. It's like it's like a car that beeps when you go into reverse because the engine's too quiet and it's trying to tell you, hey, you're in reverse. It's the same kind of thing, but Unity is buggy enough that it's like, okay, you know what? I'm just going to change your entire operating system color. And then the J is a column here, right? We're just going to be good citizens here. Kristjan reminds us to use good variable names. Not like A and B.
I mean, we're referencing vals.0 and vals.1. There should have been 1 and 2.
Yeah. So I think if we wanted to transpose, we would switch column and row here. Is that right?
Yes, because we're directly setting.
And with the sample input, we should still get the same answer, right?
We should.
We do.
Interesting. I mean, and we should get the same output with our real input too. But I wonder if we will.
That is correct. Nothing like being rigorous, eh?
Yep.
Yeah, we got it.
Okay. Huh. So either transposition doesn't matter or we didn't actually transpose anything.
Or what did I actually paste? I guess 15432. Okay, so it was also not a copy paste error. That's what I was trying to investigate.
Yeah, never type the answer by hand.
Yeah. We could sanity check that we have the right number of boards. I mean, like, what's the math here? It's basically 602 divided by 6.
Divided by 6.
Floor,
Yeah, we have
right. The floor of that, which is like 100,
boards.
right?
Yep.
And how many boards do we have?
Why is there a bang after println?
It is a macro.
Oh.
Because like what we're writing here is like essentially a var args kind of thing. Because like this could potentially have like a billion things.
Mm-hmm.
I don't know if Rust has a built-in var args. It must. But println is like really complicated. I don't profess to actually quite, really understand the depth of it. But it is a macro, and Rust actually has 2 different types of macros. It has, I forget what the terminology is, but a macro that has a bang on it. I think it's one of those. They have like an actual macro language, and so it's essentially like a really complicated templating language, right? That has a little bit of type information in it as well, which is magical. But then there's also a macro version where it's just like straight up code gen, right? Like what you define your macro as like a little piece of Rust code that actually like has hooks into like you actually are receiving like AST objects into it, and then you're emitting AST objects, right? And that's what this is, right? That's what's going on with this. So actually, I think maybe bang open square bracket is a macro, or it is a compiler annotation that is able to execute macros. I don't really know. How much more do you want me to just talk out of my ass today?
No need. I want to beat the Squid at bingo.
Yeah, 100. Okay. So we have the right number of boards, so we're not missing anything. All right, what to poke at?
Is 15,000 a reasonable number to have gotten to? Yeah, I guess so, because we're something like 25 2-digit number.
Yeah, this is saying we're too low. And if 15,000 is too low, that means it's also not too high because the previous answer in the sample input is 4,000 something, right? So in terms of order of magnitude, I think we're roughly in the right place.
Yep, I agree with that.
We could just eyeball what our boards look like and see if there's a parsing error too.
Yeah, or let's look at one of the boards. I think we did before, but we could check a little more rigorously. Let's also look at the winning board before we print its number.
Okay.
In fact, if we can print the winning board and the number we're on, we can also look at like the number list in the input to make sure like the right stuff is marked off, all that.
Yes, we're basically trying to say like, hey, did we do this? Did we do the summation wrong? Right, something like that.
Yep. Cool. So let's find the board that almost ends with 7, 17, 36.
Yes.
We can also, here, wait, while you got that up on, I can, let's do the math ourselves too.
17, 36, 56.
That looks like it. I'm just going to add
Oh,
60.
17, 36, 56. Yeah. And then is 24 in there?
It is top row, fourth element.
Yeah.
Here's how I'm
And
just going to.
the top row is the winner, right? 70, 72, 53, 54, 57, 24, 30. Right.
Yeah, so every fifth thing starting from 0 is a -1 in our output.
Yeah. The other thing we could do is we could delete this board, run it, and then see if any other board wins. What could we have got?
Actually, oh, okay, wait, the output's on screen. So I'm just going to do the math myself, make sure that we.
Okay.
28, 24, 21, 26, 73, 3, 81, 67, 7, 17, 36 gets us to 643, and then multiply that by 24. And I get 15,432. Yep.
Let's check the rules one more time. Okay, what I was going to say is like maybe you don't mark off the last number, but I think you do.
Yeah, you have to mark it before your row is finished.
Yeah. Start by finding the sum of all unmarked numbers. Yeah, so it's... Yeah.
And we see the last number marked in the output, right? There's not a lingering 24.
Say that one more time.
In our output, we see that, right? Like we've marked off the last number.
Yes, the 24 in our output, in our example, is the top row, so it's the fourth element, and yeah, it's all -1s right there.
Yeah. Okay. Is it making you nervous that the answer is 24? The last number is 24, both here and in the test input.
Is it? Oh, it totally is.
Yeah.
Wait a minute. Am I running on the sample input? No, this is the real input.
Yeah.
It does make me a little bit nervous.
Yeah, I see 24 is just to the right of your end of line. 4 past it.
Oh, I see.
No. Like your this is as long as my lines want to be marker between 46 and 78.
Oh, I see. I see what you're saying.
Numbers past that.
Yeah, right here. It does make me nervous, but I don't see how we're crossing streams here, right? Like, let me try recopying the input. Let's just be really obtuse about it. Maybe I copied and pasted by accident, right? And I need to add this new line down here. Oh, no, wait. We're doing that. We're brute forcing that.
Yeah. Yep, well, same.
So the only other thing that I can think of, if we think that this is correct...
Well, I don't think it's correct.
No,
we're not.
Yeah. Okay. Another thing we can do is just like take a look at the numbers that got called off and make sure that these are all getting marked off correctly, right? And so you were saying that it's basically up to here, right?
Mm-hmm.
So 18, that's a -1. Just do X. 99.
Not there.
39. Well, we can even be a little bit more obtuse, right? Or direct about it. We can like say, does everything in the first row exist here, right? That's a little bit easier to scan. 72 definitely does exist.
Well, actually, you can just click on the number and your editor's highlighting stuff for us.
Yes. 57 exists. 24 exists. 30 exists. 66, 84. 68, 40.
Yep.
12, 52, 48, 34, 21, 26, 73, 3, We already marked that one. 81, 67, -1. So 82 is in there. 7, 17, 36, 56 is in there. Okay, and let me just go through these. Make sure they don't highlight twice.
Yeah.
The 0 is not going to be.
And the stuff we've manually marked off matches the board output.
You just eyeballed that?
Yep.
Okay. I'm just going through, brute forcing it. So if this is the case, what it means is that there should have been another board that won before this one, right?
Mm-hmm.
I think that's what this implies. Because like we just ran the algorithm on this board, and it looks like it's correct for this one board.
Yeah, so something else should have happened sooner.
Yep.
Yep, that follows.
Okay. So I guess we just need to like print out all the boards and make sure that our parsing looked correct. We could print out all the boards in the format that they're in right now and just do a diff comparison between that file and this one.
That's a pretty good idea.
Okay.
I mean, like as much as we've been looking at this board, which is in the middle of the stack, like this one looks right. So I'm going to be pretty surprised if something else got screwed up.
I agree with you.
Unless it was the first board or the last board.
Yeah, or there's something weird with our parsing logic, right? So let's go ahead and make like a format board. Let's call print. It returns a string. And I'm just gonna do our row column thing here.
Yeah. Or we could even do we could like start a string accumulator and add the number and spaces. Oh, if we're gonna do diff, we need to justify them to 3 characters. And then whenever the index is 0 mod 5, we can add a new line.
Yes, I see what you're saying. So let mute res equals string new. And then how exactly is the formatting working?
It looks like it's right justified. Oh, not quite. Yeah, each thing is right justified 2.
It has to occupy 2.
Yeah.
Yeah. Okay. So we're just gonna do for I val in self.elements. I need to actually pass self in here. Dot iter dot enumerate, which is what gives us the tuple of the index and the value at the same time.
Cool.
If we don't want to add a new line, the first line, right? But we're saying if I mod 5 is equal to 0 and I is greater than 0, res plus, how do I do an append? Performance plus, maybe I can just append a new line like that.
Yeah.
Okay, great. And then we are just going to say if the value is less than 10, add a space.
Oh, sure, yeah.
Is that how I toString? How do I string format? Oh my god. I mean, I can be super stupid about it and do this.
But how do you tell it to oh yeah, no.
As string. Wait, what is val. Oh, the format's not working correctly. I think it's expecting a full.
What? All right, I'm looking up Rust into string.
I kind of brute force this, but this is definitely not what we want it to be.
This person says use toString.
There's toString, I think, and it has to be like a string slice. Good lord.
Wow.
Yeah. There's a difference between like an array of characters, like a buffer of characters with a length, and a heap allocated buffer with extra jazz on it that can be mutated.
Right.
Yeah.
Yeah, like native string versus class string.
Yeah, that's what it is. Boy. And what are we even doing here? We're just printing out everything, right?
Yep.
So once we have our boards, we're just going to print. Let's just print all of our boards. Yep.
Sounds good. We could do it after the push, and that way we don't have to write another one.
I was just going to return after this, just so we.
Oh, sure.
Just so we see what that looks like.
Whoa. Oh, we need to add our spaces between numbers.
Did that not work? Oh, spaces between numbers. Yes.
Yep.
Plus.
So that'll be after we add the number, we'll add a space unless I mod 4 is 0. If it's not 0. Yeah.
It's not actually a compile error. It's fine. All right. So this is our input. This is what we just printed. I'm going to go ahead and.
Wait, that's still not right. Like line 14 doesn't have a space.
1279. It's almost as if the first one is not getting that space, right? What did I do wrong?
Oh, because we did mod 4 and that counts the first one. So what do we actually want? We want I mod 5 mod 4. Is that crazy?
If I mod 5 equals 4, right?
Well, because we want the fourth element, the eighth, or the ninth element, the 14th element, the 19th element. So
I think it's just if I mod 5 does not equal to 4, right? If it's not the fourth element in a row, right? Because I mod 5 is going to give us like which element in the row it is. Yeah. That looks pretty good. And so what I'm going to do is copy my input and then throw it into another thing here. Get rid of the first couple lines. And then can I do a diff? Is there such a thing? Do I not have a diff tool?
You can in a shell.
I used to have one that I really liked. And now that I don't know what it is, I think this one's pretty good. All right, let's close that. I mean, the only problem is I don't know which was which. I think the second one is my modified input, right?
Well, we don't have to care which is which until they're different.
You're absolutely right. I think this was the second tab is the copy of the input. So that one's compare text in visible editors. Please first open 2 documents. I have 2 documents open.
Like with the split. Hit a command backslash.
Command backslash. What about, is it like command alt 2? Command shift 2?
I don't know. Or there's probably a split command if you command shift P.
Split terminal, split editor.
Yeah, there we go.
Okay, so I think I at least need to know like which one was which, right?
Well, then we can start by comparing. Okay.
So this is the yeah. We can start by comparing just like the raw stuff, and we'll get a diff on the. All right, let me just like clear that out. Oh God, I have it open twice. I think this is like a failed attempt. We close everything else. Even close the input. Let's create a new one and copy that in there, paste it. Okay, this is fairly conclusive. I'm gonna just add a new line here to make the diff a little bit cleaner. Diff.
Cool. Wow.
That diff looks clean except for a new line at the end. So we are parsing it correctly. That's the conclusion that we've come to.
Yep.
Okay. I didn't think that was going to go anywhere, so I'm not too discouraged.
Yeah, now we know.
Now we know. Okay, so but that does raise the question.
Here's my next dumb mistake idea. Did we look at each element in our board? Were we off by one and we stopped and never considered the last when we're marking?
Great question, because we marked the first row. Right, are we making it all the way through the board, is what you're saying.
Yeah.
We're definitely making it to the end. We're definitely making it to the last column, right? Because we were able to mark off the last column. And in fact, I think we're making it to the last column here, and we're making it to the last row here. And we were actually able to mark off the very last number.
Yep. Okay. Yeah, and our last iterator is going to be 4, 4. 4 times 5 plus 5 plus 4 is 24. So that fits. Okay.
Yeah. Oh, and then in chat, sorry, Reese's Snowbell, I think I might have missed this comment earlier, but they were offering if, I could send our input to them to make sure that it's correct. I like that option if somebody else was doing it, but I'm not quite willing to give up on this just yet. You know what I mean? Like I feel like there's got to be something that we've done. Well, here's the thing is, our marking is working correctly, right? We know that we're marking correctly.
Yep.
But maybe what you were asking is is our checking correct? Well, we transposed, right? It feels like with the transpose.
Yeah, it seems like that should all be totally fine.
Yeah.
Well, so going back to our hypothesis that it was an earlier board that should.
Yeah.
Are we doing? Like, it feels like we're not doing wind detection correctly.
Yeah. Well, that's what this is. That's what this function is, right?
Yeah.
And we were able to do wind detection on this one, right? And the transpose of this.
Wait. When we label for loops and then you say break out of this for loop.
Yep.
Is that like break out of, so like, break row on line 26. Is that break over to the row for loop, or is that break out of the row for loop?
Oh, you know what? That might be it. This might be continue.
We're only looking at the first line.
Yeah, that's it. But that's not what I want to do because we're doing a bunch of debug printing. Let's get rid of this. I didn't want a PP copy. I just wanted to print it out. Okay. Hey, that's a higher number. Okay. It probably would have taken me like another hour to figure that out.
It's always the smallest thing. Hooray!
That was this tiny thing. All right, I'm going to read out the second description, and then thanks, Arisa Snowbell. Appreciate it. Asperos7DC says that they've already solved it, but it's in C#, a single link query. Nice. I don't know if you know what link is, but C# basically has their this magical, I think it's like a React style thing where they actually have an alternate syntax where you can basically do database style operations on data structures in that language.
Cool.
It's a lot of cool dot chaining stuff. On the other hand, it might be wise to try a different strategy, let the giant squid win. You aren't sure how many bingo boards the giant squid could play at once. So rather than waste time counting its arms, the safe thing to do is to figure out which board will win last and choose that one. That way, no matter which board picks it, it will win for sure. In the above example, the second board is the last to win, which happens after 13 is eventually called and its middle column is completely marked. If you were to keep playing until this point, the second board would have a sum of unmarked numbers equal to 148 for a final score of 148 times 13 equals 1924. Figure out which board will win last. Once it wins, what would its final score be? Okay, this doesn't seem like it's going to be a performance issue, right? So I think what we're just trying to do is we're just trying to keep track of which boards have won and then remove them, right?
Not even which boards have won. We can just keep track of the most recent winner, go through all of our numbers, and then we have it.
Okay, great.
We need to remember the board that won most recently and the number.
It's just a board, right? And then actually, I think this one's just going to go down here, right? And oh gosh, I should have made a constructor for this.
Ooh, actually, you might be right about removing the boards as they win, because otherwise they're going to keep coming up as one if we don't start ignoring them.
Okay. Okay, so what is the right way to know? Maybe we'll just keep a list of indexes, like who won. We could also remove them from the list, but then
yeah, let's just remove them.
Let's just remove them. Yeah, let's just remove them.
Let me get faster as we go through.
And then I'm going to call this board because it's confusing otherwise. If board has one, they're saying if boards dot length is equal to 1. Why did I delete all that code? Then this, right? Otherwise, we're just doing boards dot remove the board number.
So we might not get down to one board. There might be like 20 boards left, but the 21st was the one that won last.
How is it? So you're saying it's possible that some boards will never win because
yeah,
we've read through all the. Okay, I see what you're saying. So we still need to just know what the last winner is. Is that what you're saying?
Yes, or actually, yeah. So either the last winner or an ordered set of the boards, and we like fill it in with their board index as they win, and that'll let us both ignore them and keep track of the last one.
Oh, I see what you're saying. Let's just do a vector is what you're saying. So like let winners equals vec new, right?
Yeah. And we just like throw the board index as they happen.
And then so what we're saying, if the board has won, first of all, what we're doing is we're saying we're going to ignore any board that's already won. So if winners dot contains the board number.
Mm-hmm.
Where's my autocomplete? Then we're just going to continue, right? We're skipping it. And if it has one, we're just going to add it here.
Mm-hmm.
And that's it.
Yeah.
And then what we're going to do...
But we can wait if we want to.
What'd you say?
There's no harm in printing every one. We'll just like look at the last one, or we can wait.
Oh, I see what you're saying. Yeah. Yeah, let's just do that. We'll just print them. So we don't even need to keep track, right? You're just saying let's just print them.
Yeah. Oh, well, we do need to keep track because otherwise we're going to print everything like n times.
I see what you're saying. Winners that contains board num, which is a U size. Is it just having a hard time because I didn't actually say what this is supposed to be? Oh, I need to pass a reference. That's right. Gosh.
Oh, actually, you might be right. We might not actually have to keep track. We're just going to get a bunch of output. A bunch of it will be repetitive, but we look at the last thing.
Well, yeah. I think it's okay. I think it's okay if we do this. Winners dot push board num. And winners needs to be mutable every time, which is fine. That's what you want, right? And then let me just double check to make sure it's just complaining that I have to try to import a bunch of extra stuff. Print is never used. That's fine. I'll let you complain about that. 2634.
Wait, did we multiply that?
We got it. Yeah, we did. Sorry, I went so fast. I just copied and pasted, so the multiplication is happening right there. Well,
oh, and of course it's a smaller number. It's got the same number of stuff marked out. Just happens to be a smaller number.
Yeah. All right. Well, that was really fun. I'm so happy, Kristjan, that you could come in and do this. We could do this together.
Me too.
And it's fun for me to be able to talk about Rust, and then like what I know about it, and what I don't know about it. Hopefully, you learned a little bit about it. And I definitely wouldn't have gotten past that continue break bug, which was a language issue, right? If I did not have you along. Because you're right. Break row just basically says break out of this loop. But continue row just says like continue this loop immediately.
Yep.
Yeah. I guess this is the kind of foot gun. People argue against using continue in languages. It's weird. There's some languages that don't have continue.
Really? I mean, I guess you can simulate it with an if else in the loop.
Yeah, I don't agree with that sensibility. But does Go have continue? It does. Okay. I feel like there's some languages that are like, no, you shouldn't have continue. It's dangerous. And I'm like,
huh.
That's just not my philosophy. My philosophy lately in programming has been to like reduce indentation radically. And I think continue gives you that, right?
Yeah, it helps.
Yeah.
Yeah. Do you know like what the objections are? Like, it's a little bit of a go-to, but so is break.
Yeah, I think it's basically that it's go-to. Here's the thing: is I like that is the superficial statement of the objection, but I don't know if I understand the philosophy behind it. Right?
Yeah, because it's not go to an arbitrary place like somewhere in the executable. It's go to this very local thing.
No, but like the way people talk about it, and again, like this is like third-hand knowledge from someone who's biased against the argument, so you have to take it with that amount of that grain of salt. But I think what I've read about it is just the complaint that it leads to spaghetti code, which is the same thing it's the same complaint against goto. But I've always felt like continue is a very useful thing for reducing complexity in a loop. So
yeah. I mean, it to me it feels much more like syntax than goto, because you could implement it with an if, you could implement it with a filter on your input before you start. Like, there are lots of more complicated and annoying things to type, and continue just makes it easy.
Yeah, because like if you didn't have continue, what you would basically like wrap everything after that with an if, right?
Right. like if this empty if
and
statement,
declare a new variable, right? You would declare a new variable to like
yep.
to put into the if, and that seems to me like an order of magnitude worse than whatever spaghetti that you add, and it's not structurally any different. You know what I mean? Like it's not actually any different semantically. Yeah. That's that.
Well, if I meet somebody who is vehemently against continue, I'll pick their brain.
You know what? I might just be like inventing the argument, and we're just like being angry about people who don't exist. How about continue is an anti-pattern? Is that going to come up with anything?
Or continue considered harmful? Hey, here we go.
It's gonna say never use the continue keyword. Musting
Yeah.
Mortaray. This is a name you can using Mortaray. That's a name you can trust.
With a name like Mortaray, you know there's pretension involved.
Yeah.
That's not even ad hominem. That's just ad nim.
I don't see this as a. Oh, you know what? Are they arguing against this? Is a common recommendation? Yes, but you have. Oh, this person is arguing in favor of the continue keyword, it looks like.
Yes. Yep, they sure are. But maybe they have the arguments that they're tearing apart in here.
Yeah, maybe they're yeah. So they're saying someone recommended doing this instead of this, which is idiotic. And by doing this, you have not modified the meaning of the code at all. I completely agree. That is the exact argument, right?
They just move the loop.
Yeah, exactly. And like I am kind of like I have this conversation with Ryan Greenberg a lot, where like later in my career, I've kind of been against factoring out functions if I don't have to, even at the cost of like a longer function.
Interesting.
And I think it's because, like, to me, a function has, and this is just like a language thing, but like a function has additional meaning besides like giving a name to some code. It like creates an abstraction layer.
Mm-hmm.
And I guess what I worry about with functions is someone else calling it, right? If the goal of the function is merely to like make a longer function more legible, I'd like to be able to do that in a way that says like, hey, you shouldn't actually use this as an interface, right? And I guess there are ways of doing that in a really rough way, like private and public, right?
Mm-hmm.
But if you had a really complicated class, your other function could still call that private function, right? And the programmers on your team are still going to be able to call it. So I don't know. I don't know if I'm making any sense right now, but like,
well, like it's not an excuse for not understanding the code. I think is some of what you're saying.
Yeah,
but it does like, yeah. I mean, I think I feel like we've talked about this before too.
Okay. Yeah.
I think I'm on Greenberg's side of like I prefer more functions and more, because I do think a function is like a little blob of encapsulation and it should do one thing.
Yeah.
And like maybe that one thing has 3 steps, but if it has 12 steps, maybe I'm not really doing one thing.
Yeah. Yeah, I think that's right. I think it gives a name. Like, I think if you can, I don't know. I mean, like every time I've like opened my mouth, what I immediately come to is like, I assume that a function means reuse, and like if that's your assumption, which I'm saying is like there's like a lizard brain part of me that basically that's true for. If that's your assumption, then it changes your philosophy towards it, right? But clearly, in your and Greenberg's case, it's not that you writing the function for reuse. You're trying to give a logical name to something, right? And then not trying to clutter something larger, right?
Yeah, well, and in some sense too, like once you get into testing philosophy, like that is a reuse. And so if my function has 12 steps, I'd probably like to be able to test the substeps. And so I'm going to go reuse them in the test, even if I don't reuse them in the implementation.
Yeah.
But I wonder if you'd be happy with more functions if like there were a language feature where you could say like this function is private to this parent function.
Yeah.
To avoid like the calling you're complaining about.
I think that would help. I think partly it's also like, and the thing is like, I don't want to like overstate my case. Like if a function gets like really, really long, or if I really feel like there is a piece of logic that could like really stand on its own and be comprehended on its own, I'm fine with factoring that out into another function. You know, I don't want to like overstate this too hard, but it's like there are times when like you can pull out a piece of code because it's just like how strong is the logical barrier there? Like if you factor out that function by itself, is the purpose and goal and mechanics of that function legible in and of itself? Or do you have to know that it's part of some other sequence of things? And if that's the case,
Right,
then I
yeah.
start to ask questions like, was this worth factoring out, right?
Mhm.
So my criterion is not really about the length of a function, like am I going to factor it out or not? It's like, can it be separated into like logical steps that can be understood and read on their own? I think that's basically it. Maybe that's a
To do
more
them
sophisticated
by
explanation.
themselves. Yeah.
All right. Well, it is lunchtime. I think I want to let you go, but this was really fun. I really hope we have an opportunity to do this together again, and it would be great to like also just get some coffee sometime.
Yeah, I'd love to. Let's do that soon.
All right. And folks in chat, thank you for stopping by, especially Arisa Snowbell, giving us advice about Rust and everything. And thank you for joining us. And probably be on 9 p.m. tonight if I have the endurance for it. Otherwise, we'll just do this again tomorrow. All right. Take care, everybody.